Hello, my name is Luis Lozano, and I will be talking about the payroll attrition project we're working in a bank, and some stuff about the CRISP DM, business understanding, and many things we will cover in less than 5 minutes. Okay. So first, why is this an opportunity, an attractive project to work on using machine learning? First, because the problem is to estimate the probability of a customer to attrite from the payroll portfolio. So we're dealing with customers that lose or change job, and we're willing to offer them a payroll credit. Okay, so we're going to be focusing on the low probability customers. It's attractive because it is an actual problem to offer correctly the products. This can reduce the fraud losses, market targeting costs, and it can also enhance segmentation and product allocation. ML can solve, and actually there is a model in production, but it needs to be slightly modified to be enhanced. The bank cares about this because this is how credit cards, loans, and other products are sold. So as I already said, the target is the customers that work for any business whose payroll portfolio is owned by the bank. It is solved. It is already solved in production using a GBM with 10 features. There are some gaps since it is a static model, and we're willing to make it a dynamic model, which means that we're going to be fitting on new data and the parameters and hyperparameters. Success for this problem is guaranteed when we increase or at least hold the percentage of customers that will correctly offer a product without attrition in the model. Some of the constraints we have are given by the information. We only know the movements in our bank, so that is the data we have. We don't know anything else outside of the information they give us, like some transactions with other banks, how often they're looking to other job opportunities. That's something we cannot know. And it is considered attrition after 3 months of not receiving a payment. So the output to be used is the probability and the outcome, the probability of attrition, and the outcome is given by the correct prediction of the unemployment attrition. Okay. So some relevant factors include that this model can be used to predict credit for new customers outside this population, of course, using other features, right? And the development of a general framework for dynamic models to be implemented by every coworker. So that is the main purpose, like to create this framework for other projects. The solution will require updated data connections to create a model that recalibrates or recalculates from random initialization every month to prevent attrition on the model. This can be done using an A/B testing for every new period with 2 samples and comparing the results. Now, maybe if the model that is already in production, if it doesn't draw the metric a lot, we'll leave it there. So we're going to be using an edge model that doesn't drop the output metric. It will recalibrate the model faster to include new data, but with a latency of 1 month. So the calculations are created monthly and will be sent uniformly along the months. So because the information is not obtained immediately and the model cannot obtain the target very quickly, it is proposed to have an offline learning. So it doesn't have to be learning immediately. And finally, since there are explorations needed before deciding to deploy a new model or not, it is considered to be using batch predictions. Okay? So this is not going to be using some device that needs to be predicting on the go online. So it's okay using batch predictions at the end of the month, and then at the beginning of the next month, we open those predictions to the campaigns. So there are some potential risks in production. Actually, some issues were observed and will be tackled, like concept and data drift. But there is yet some latency, and as well seasonality could appear, as well as economic factors that are external to our features. So thank you very much.